Yes, ma'am. See here, I substituted the value of R and value here. So what it became? Pi will get cancelled. Then anything will get cancelled now. The answer is becoming how much? MEN is equal to what? This is energy. Energy of the nth orbit is equal to what? Minus E square, and E square will become E power 4 by 8 epsilon 0 square n square. M also will come up, and H square. Okay, this is the value. This is the value of the energy of nth orbit. Now in this again all are constant. See here, E is constant, charge of electron, M is mass of electron, epsilon 0 is permittivity of free space. What is permittivity?
So it's the membrane.
He will say, wait, he's just looking at you. Yeah. Tell me.
Sir, permittivity is a license for
Has to
an
be, not
electron
has to.
to enter a space.
Oh, space. My grandfather will come now. Enter in, he will go with you in space. It is a property of the medium which allows electric lines of forces to pass through it. Permit, I told no.
Oh yeah.
Permittivity means, remember it, permit.
Permit.
License.
License.
Okay.
So I remember the license.
Then how did you forget then?
I told
Space,
license.
It's a property of the medium which allows electric lines of forces to pass through it.
through.
That is permittivity of. If it is free space, we say free space. Otherwise, of vacuum or permittive. Otherwise, it is a permittivity of medium. Permeability means?
Sir,
The membranes.
Sir, the concentration of permeability, like the amount of permeability that it can provide.
Same it is. Only magnetic field.
Okay.
Permittivity, permeability is same. Permittivity is for,
Sir,
Electric current.
we didn't come here
Field.
for term 1
Field.
portion, so we don't
Field.
remember.
and that is for magnetic field. Electric field, magnetic field.
Magnetic.
What is the value of epsilon 0, my dear?
Oh.
1.9.
He will say.
No, sir.
Now what you know, only the stories, 8.85 into 10 to the power of minus 12 coulomb square per Newton meter square. What is the value of 4 pi into that permeability value is 4 pi into 10 to the power of minus 7 Newton Tesla meter per ampere.
Sir, what is Tesla?
Tesla is the unit of magnetic field.
Magnetic field.
Flux.
Flux.
Okay. Nikola Tesla.
Yes, sir.
His name is Nikola Tesla.
Yes, Tesla or Elon Musk's Tesla.
No. Again, he is
Tesla is one of the biggest scientists, most respected scientists.
I know when
Tesla.
that guy made the Tesla thing.
Tesla tower, yeah.
Yeah, he's
Okay.
the one
Is
who
it
made
clear all of you?
I know
This
that
one.
too.
Please copy this one.
Invisible.
You want just call Joshua and Sayam also. Zayan, is it clear all of you? Zayan.
The place is there where you can see because it's black market.
So you can off this light and then put this light.
What do you want it like that?
No, I'll remove this and fix it here better.
Yes, sir.
That will be okay.
Yes,
So
sir.
you use your own or is you call someone?
No, we can fix it. No, what is there? Nothing is there. Just it is like remove the strip and fix it here. Finish.
Something that's smoking.
This small thing only, no, not a big thing.
So we did.
But I need something to drill, no?
Yes, I have an impact gun.
That wall drill.
Yes, I have the impact gear.
Then bring it tomorrow. We'll do it now. I think there is no wire here, no? Go it, that won't be a problem then.
Yeah.
Yeah.
Then it will be really
So,
nice.
but this must be a gypsum board because there's an AC over there.
Which one? This one?
Yes, sir. No, so like a top side might be a gypsum board.
Yeah, that, we are not going to that level, not just below that.
Just above the board.
Here.
Then you can't see the board because it's so bright.
Yeah, maybe. Again, it will be a problem.
blind you.
If it should be like this actually. Should be on the roof.
Yeah, roof.
Oh.
Yeah.
Yeah.
But this roof is like this. What will do?
Change
There's no fan. Oh, yeah, there's no fan.
Change house.
AC is there. That's it.
AC is there.
So change the house and come to my building.
Yeah, that. I come to the area.
And then every night I have to wake up and stand for some, sit for some.
Sir, your school is near my house.
IPS.
No, it is in Azra area.
Dubai.
Azra, Al Azra.
Yes, sir.
There is near to Ajman.
So
Okay.
this is near that.
As one is here, on you can go to all of them.
Yeah.
Yeah. Joshua, try Joan. Where is he? Just check with him. Now, so we found out the energy of nth orbit. So when we substituted all these values, man, so we got En is equal to how much? En value is equal to minus 13.6 divided by n square. That is electron volt. Okay. Minus 13.6. Sorry, I'll write this is in electron volt. if you want to write in terms of joules, it will be 2 minus 2.18 into 10 to the power of minus 18 joules by m square. See, you know what is the value of electron, how to convert electron volt into joule? How will you convert?
They divided by something, right?
How much?
1.6 into 10 raised to minus 19.
1.8.
Very good. 1.6 into 10 to the power of minus
I did it in
19.
School, yeah, I remember.
I
Yeah,
also
that is
taught
how
them
you
that
convert. That is how you convert
Joule into kilo.
joule into electron volts.
Yeah.
Okay, so that is the reason. Okay, that's it. So this is minus 13. Why minus? Minus is for attractive,
attractive
because
it's attractive.
electrons are attracted to towards the nucleus. Okay, so please take down this picture and then you can go ahead. Just take the screenshot. So almost all the derivations are done. Only have to explain the energy levels, the last line spectra of hydrogen atom. That I have to explain.
Yeah.
We don't know, man. The CBSE are like, you know, crazy guys. We don't know. I
So
don't.
you also accept that?
Huh?
You also accept that CBSE is crazy?
They want to do something like out of the box, but they're going to trap it.
They want like more number of failures in our country.
Not more number, actually, you know, that's not like that. Actually, they want to check, like, see, there are good schools like in India, especially North India.
Delhi.
The competition is very, very high.
Delhi public school.
So if you give a little easy paper, they will get 100 or 100.
Yeah.
That they don't want. Okay, 1 or 2 is getting, okay, few are getting, it's okay. Like 100 people are getting 100, not a problem.
So then make
But if
separate
it like
papers.
thousands of people are getting 100, then that means that standard of the paper is very low. You understood?
Yeah.
That is the reason they try to do that.
They want to bring more competition.
So then
If all are getting, like now I told you, in like now the cutoff mark in Delhi University was 100%.
because of this.
Yeah, miss, even 100 who are getting 100 also not getting the seat. Then what he will do then? He has to jump from somewhere. No other way. Right.
I got 100, I studied so fast.
Even after getting 100 marks also I'm not able to get a seat. Then what I have to get now?
Then I jumped.
You understood?
Yeah.
100% also this is not so.
Sir, with that 100%, they get full scholarship in MIT.
But this became a COVID batch. No, in COVID batch they didn't do MIT.
For COVID batch they simply took in MIT and all.
MIT.
Yes,
Yeah.
sir.
But the percentage reduced, you know.
Yeah,
Indian students they reduced. You know that in Oxford University also they did not give. Actually, it is 2% of something. That intake was not there this year. You know. They didn't take. Most of the universities didn't take Indian students because they went with an internal valuation.
So do you know
So this guy got 99%. So what he did was he reduced the marks to make it minimum for the universities. He's that smart. He's doing quantum physics in Oxford.
Good, that's great.
So do you know Gupta?
No, I don't know.
The topper of physics. So he was teaching math, like our school teacher. He was
From our own.
So full UA knows that guy's name. Everyone knows him.
That guy was teaching teachers.
No, it's not like that. But maybe his way of understanding is different. See, I will tell you what exactly happens with the physics thing. Every person understands the physics concept in a different perception, a different idea.
Yeah.
Chemistry doesn't happen like that. English it doesn't happen like that.
That is all by
The problem, mathematics also doesn't happen like that. It happens only with physics.
Yeah.
The way of acceptance is different. So the teacher has to bring them all in a same platform actually. The role of physics teacher is little difficult because he has to bring all the minds at the same platform.
Yeah, they have to make
You understood? What you understood, the concept of light, especially light. Suppose simple example we give. When an electron is jumping, when you understood that when an electron is jumping, then everyone understood in the same pattern now.
Yes.
Yeah. That means your job is done. You fulfilled your job now. Means this concept everyone understood in the same way.
Yes, sir.
Now spectroscopy concept, what happened now? Earlier, students were not clear what is spectroscopy. That was the beginning. Now when you gave simple example, so sample detector, finish. Everyone understood in a general fashion.
Yeah.
That should be there. Understood? That is the thing, like when you start explaining the physics, everyone in the beginning will take in a different way. You have to bring them on the same platform. Got it? So, especially this happens more in electrostatics, rotational motion. These chapters are little difficult to make the children understand. Okay. Simple example to understand rotational motion is a torque. Beyblade. Top, yeah?
It's a top, yeah.
Top.
We do this in
Beyblade.
Yeah.
These are all the examples. Understand? So now, anyways, we'll go back to the next one. So if you can understand this, now again, how is the electron exactly moving in the orbit? That is the question.
Oh, it's
What we said, okay, it is moving around the electron is moving around the orbit in a around the nucleus. Actually speaking, electron is also spinning around itself, right? Electron is also spinning. Then how it is spinning? Is it spinning symmetrically, asymmetrically? How it is? It is like electron sitting on the top.
So if it is moving in anti-clockwise, then it's spinning rightwards.
No, that is okay. Anti-clockwise, clockwise, that is a different thing. Okay, we know that upside down, upside and down. We go up spin, down spin, we give.
Yeah.
That's a different thing. I'm not speaking about that. Now, scientists have explained in a different way. You know, the top, top.
Yeah.
This what is it?
Beyblade.
Yeah, I don't know exactly what is it.
Yeah.
The top like this. The children play, no?
Yes.
That's a top like this.
Yeah. When it will move,
Yeah.
when it will rotate rightwards,
Yeah.
it will move left.
No, that is okay. That is okay.
Okay.
Now, electron, he says that electron is spinning. The electron is spinning like a top.
Yes.
An electron is sitting here.
Okay. Yeah.
You understood?
Yeah, makes sense. Yes.
So electron is spinning with an axis like away from it. So like around the axis. Right?
Not only that, again, this is symmetrical top. Means exactly the rotation is also on the same axis. Now, this is something interesting, you will understand. Like exactly what exactly is happening. So, now this is the orbit again.
Okay.
Now, this is the axis of the orbit.
Okay.
Now, this is one more top, one more design of a top. See? Electron is sitting here. This is asymmetric top. Around the axis.
Okay, so it's like circle over here and then go circle like that.
Means now how it is happening, like suppose if the top is rotating like this.
Yeah.
It's okay, symmetric. Around the axis.
Yes.
It's like small circle around a big circle.
No, you have to play, for that you have to play the top. In the beginning it is spinning like this, when it is stopping,
it's losing the
that inertia,
yeah.
it goes around the axis.
Yes.
Did you see that?
It's
For that you need to have a top with a very narrow thing and one broad one.
Yeah, narrow tip and a broad
Narrow
tip.
thing and the edge.
Oh yeah, a narrow.
What we say, I don't know. This portion, no?
Yeah.
You have to take one narrow one and one wide one, which is wooden, no? Generally wooden mold.
Yes.
So one you take narrow one and one you take broad one. Then you will understand.
It's like on the circumference of the broad one, put a narrow one. Yeah. And then on that circumference, put the electron.
No. You understand. So you take two and spin it two at the one time, then you will come to know the difference.
Okay. Sir, but then, so that's how small electron is.
You understood now. So they say that a philosopher says, really, if the God would exist or the God exists, it should be on the tip of the electron. It should be like a hat on the electron, which is revolving around the orbit on a top.
So, but how do they find this?
This is quantum. When he told me quantum mechanics, then I try to explain this thing.
Yeah, I know this.
Quantum mechanics is something like which is micro and nanoparticles.
So, but
I was teaching for a long time quantum mechanics. So,
but how do they find this?
That's what you need to have higher. This is not to this level.
Can't look through microscope here.
This you have to understand more. First of all, you should be very clear with what is. We have 4 quantum numbers: principal quantum number, orbital quantum number, magnetic quantum number, and spin quantum number. These are the 4 quantum numbers which you study in chemistry. Principal quantum number tells about the orbit. Orbital quantum number tells about the orbital, whether it is s orbital, p orbital, d orbital, or f orbital. Magnetic quantum number, can you explain? Teachers, they skip. I will tell you what exactly is happening in the classes. I know as a teacher. They explain very nicely orbital quantum number, azimuthal quantum number, or orbital quantum number. Magnetic quantum number, they say that minus L to plus L, minus L to plus L, 0 including. And spin quantum number, spin down, spin up, spin down. Yes, anti-clockwise, clockwise, spin up, spin down. That they explain. Magnetic quantum number, how will you explain? To explain magnetic quantum number, then again you should understand what is Zeeman effect and Stark effect. Zeeman effect means when these spectral lines are moving, no man, from the source. See, this is the source, this is the sample. Okay, this is the detector. When this light, okay, whatever the X-ray, whether it is X-ray, whether it is visible light, whatever it is, You took some line, and when these are the lines which are emitted by the sample.
Yes.
When they are going, you place one, you keep one magnet here, north and south pole magnet. Then what happens? They start splitting.
Yes, they will.
The lines will move away from each other. They start splitting.
Which lines?
These lines, these rays, which are going from the sample to detector, on its path you keep two magnets on the side, left hand and right side of them. That lines will not go; they get split. Instead of going narrowly, get widened. Then you will get on the spectrum you will get some lines. This type of effect is said to be Zeeman effect. Splitting of spectral lines in the presence of magnetic field is Zeeman effect. Splitting of spectral lines again in the electric field, Stark effect.
So how does it split in magnetic field?
That race, because that force is exerted on that one, right?
What force?
Magnetic field or magnetic force is influencing that line, right? What is electromagnetic wave, man? It is having two components, right?
Yes, sir.
Electric component and magnetic component.
Yes, sir.
Will not the magnet and magnetic component interfere then?
Yes, they will.
Sir, but then how is it getting wider?
I will okay. 1 second. In an electromagnetic wave, we have two patterns, right?
Yes, sir. Magnetic and electric.
Like this.
Yes, sir.
Yes.
Suppose this is magnetic field, man.
Yeah.
Yes, sir.
The magnetic field is going like this.
Yes, sir.
Now I have applied external magnetic field now.
Yeah.
My external magnetic field, will it not influence this magnetic field of the
Yes,
plane?
sir, it would.
It will influence.
Yes, sir.
Maybe it can go close, it can go away, it can go maybe in a different direction.
Yes, sir.
Yeah.
And doing that, like in that fashion only, it will go and it will hit the screen.
Okay.
That line is formed.
Sir, but how is the ray getting wider? That is
Not wider or narrow. Maybe that force is like, suppose the wave, the amplitude which was before like this. There are two amplitudes, right? One electric and magnetic.
Yes, sir.
It will not remain the same amplitude now.
It will change. It will alter.
One wave, the amplitude, the frequency will
negative.
change little.
Okay.
Yeah.
And due to that, what will happen?
Oh. Sir, but then like
You to understand all these concepts, you need to understand little higher knowledge. You got my point.
Yeah.
Now you understand in physics. Physics is not so easy now.
It's awesome.
It's so depth. Okay. First you understood only electromagnetic wave, little. Now you are applying magnetic field to this one. It's not so easy to understand. So what happened to that force is impacting on that that plane, magnetic plane.
Yes.
So what will happen? Due to that, what happens? The splitting of spectral lines will take place.
yes, sir.
Spectral line here on the screen. So that we study. That is what magnetic. What is that quantum?
Magnetic quantum.
Teachers will not take that risk. They will say, okay, let it go. It is going easily. Let it go. Minus L2 plus L0. Students are also happy. Children are also happy. Finish.
Sir, I didn't understand this whole thing when ma'am taught.
You understood now?
Ma'am taught.
Yeah, ma'am taught this.
This is very, very simple.
That coordination
But
number here.
same thing. Now same thing. If you place electric plates instead of magnetic plates, if you are taking electric plates, what will happen? The plane of electric field in the electromagnetic wave, it gets disturbed. Something will happen to that. Something will happen to that. Due to that, what happened? The pattern which was there before will not be the same before now.
Yeah, because it will change.
The difference is there, right?
Yes.
That is Stark effect.
We'll ask Lazy ma'am to explain this. Do you know this? You know.
No, it's not like that.
Sir,
It's not like criticizing anyone, but when you're clear with the concept, you'll have a sleepless, very nice, peaceful sleep. Yeah, I understood this concept.
Sir, but then like it won't always get wider, right?
That I will explain. I will explain this not now. Let me finish off this nuclear physics and atomic physics. When I am leisure, I will explain all that. It's all are related to spectroscopy and quantum mechanics. Okay.
So when I built spectroscope, they didn't teach this a lot in that internship.
No, this is at a lower, very microscopic level. No, it's not like normally. You to understand this, first of all, you have to study so many books. It doesn't come in one book actually. When I was in university, I'm telling you, to teach one subject, I used to have refer 13 books. You can understand one paper, or only 8 units or 4 units.
So university is all about studying, no fun.
It is there, but
Studying is fun.
in research we have to go to that level. When I'm teaching to the PG level,
they will teach chemistry. Also.
See, you are plus 2.
Doing PG, that's
As a plus 2, you are having so many doubts, right?
Yes.
I'm trying to clear as much as possible.
Yes.
Think about a student who is having same knowledge, higher knowledge of 5 years. Maybe PG means after 3 plus 2.
Yes.
Yes. previous and final. That means after maybe he's
third year.
Maybe he's like 3 years degree and 2 years PG.
Okay.
I was teaching PG. Now you can understand a student who is a topper in the university, not like just like that. This student who sits in my class is a cream of the university, who is having topmost rank in the entrance examination. That we say cream. He is there in the class now. Like 30 students are there in the class. I mean, all are intellectuals, right?
Yeah.
All are having good knowledge of physics, good strong knowledge of physics.
Basically,
when I am teaching here, I should have that much knowledge, right?
Yes.
So you have to prepare that much and go. It's just not like
only to learn more. You have to prepare.
You have to prepare. You understood now?
Yes.
So that is why university professor will not have that many classes. They have hardly 16 classes.
Per year.
Weekly. 16
that's
hours.
A lot.
Huh?
That's still a lot, right?
16 hours. In that also practicals will be there. Means 3 hours practical, 3 hours practical. How many?
6 hours got, so 10 hours.
10 hours hardly. 10 hours, 60 minutes. We teach. You understood now? So that much.
So you study then teach. That's a job.
And do the practicals,
Study,
and the remaining you will do. The remaining time you will focus on your research. Research paper publishing and all.
So the full time study will take.
So when you publish, do you get money for publishing amazing
This
stuff?
is not YouTube, my dear.
So you should leave your job, go focus on YouTube, sir. You will earn a lot of money.
So this is what he did. What there is a Han Academy. Han Academy. He started explaining simple concept to the students.
Yeah.
And he started recording that thing before, and he started uploading. Then after that, he got the project from Microsoft. That is how he became very popular. The only thing is, children were not able to understand simple concepts.
Okay.
You understood? In our school, what we are doing, we are only worried about to complete the syllabus fast.
Yeah, exactly.
And conduct the examination.
Yes.
This is what is happening in our schools. Okay. So we have to see that our children are understanding the concepts clearly, properly.
So they are studying only for the sake of exam.
That is
Sign-ups.
Okay.
So there was one experiment. We were doing practicals.
Yeah.
There was one experiment in the side 11th grade. So we were asking about teacher, and suddenly this one guy came. He's like, "What is this experiment? Should we do this?" We were like, "No, this is for 11th." Then why you are saying just go? He was like, "Good."
So now, okay, that I was saying, no, in magnetic field, if it is splitting in magnetic field, we say Zeeman effect. Okay, this I will teach later on. Okay, Zeeman effect. You can just type this Zeeman effect on the Google and go to the pictures.
Yeah.
You will see that in the dark room how they do the experiment. And if you are doing the same thing in electric field, you just type this Stark effect. Okay, this you will find in these two are there. Later on you can check, not now. Okay. These are the two split, how it splits. Pictures are there. No need to go to study all these things. Just by understanding, looking at the picture, you will understand how it is happening. Okay. Stark effect and Zeeman effect. Okay. These are the two scientists who did this.
Do you know working of an arc reactor?
No, I'm not that. I have to read once. Then I will understand.
Accelerates the particle and the hits.
Maybe it is something like nuclear reactor only.
But
in the high voltage plates we will keep and we will apply, you know.
Yeah.
That's something.
So there are magnets like in an angle which propel the atoms in
plasma will develop inside.
Yeah,
something is there. Something.
But then you need to cool it down, otherwise
that is there in Spider-Man.
Iron Man.
Spider-Man 2, I think it is there. The Professor Octopus will do, no.
He is making sun. He is making artificial sun.
No, star. That is also arc only with the help of arc.
Yeah.
Fusion reaction.
Fusion reactor.
There's a fusion reaction he tries with the octopus.
Yeah.
Okay. Anyways, we'll go. Yes, we are so much. Okay. If you open that window, no, physics window properly, then you will so much is there which will start coming.
Okay. That guy basically made a nuclear bomb, open nuclear bomb. That a fusion reactor, right? In an open space.
Could not control that.
Yeah, of course he won't be able to control it.
But it was an experiment. See, that is how from the movies you learn. See, how did you come to know many things? Because of movies. When you saw movies, new things.
The curiosity, they want to know more about that thing.
Now, the next one is what energy level. So we will speak about the energy levels. How is the energy given? Okay. So energy level. In energy level, you have see this is the ground state energy level. You can understand now. N is equal to 1. The energy is how much? If N, suppose This is E is equal to what? E1 equal to how much? Or I will write minus 13.6 electron volt. Okay, this is the total energy. Total energy in electron volts. Okay, minus 13.6. This is N equal to 1, ground state. GS, ground state. Now see that difference. That is the remaining. Next, when you substitute 2 there, it becomes 3.4. When you substitute 3 there, it becomes minus 1.51. If you substitute 4 there, it will become 0.85. If you go like that, it's the same. Continue with that. Okay, continue with that, it will become 0. At infinity, it will become 0. So that is unbound ionized state. Unbounded or ionized state. Or ionized state. Okay. See that these are all n is equal to 2, n equal to 3, n equal to 4. Okay, these are all what? These are all excited state. These are all excited states. Is that clear?
Yes, sir.
So this is what about the energy. Please note down this. This is the very important, because the next one, if you go to the nucleus, it is 0. There is why? See, what is the meaning of negative decreasing? What is the meaning of negative decreasing? See, negative number is minus 13.6 became minus 3.4 minus.
So negativity is decreasing.
Attraction on the outermost electron is decreasing.
That's decreasing. Okay.
Attraction of electron on the outermost orbitals is decreasing. So that is why the electron which is in the outermost orbital doesn't have any attraction towards the nucleus. So it can be easily
there is no negativity.
Away from the nucleus, so it can easily be removed. Understood? That is how, again, from that ionization energy came up.
Sir, but then that electron won't have completely 0, right?
That's the unbounded ionized. That's what I wrote. Unbounded.
So but then the electron, it will have some kind of attraction, right? Not like 0.
If it is 0 means completely infinity, means it is in the ionization state now. Means electron is completely out of the nucleus now, out of the orbit.
Exactly. So it can't be 0 when it's inside the atom, right?
Inside the atom, no.
If
it is orbiting around the nucleus, definitely there should be some negative value. The energy of the, this is all energy of the orbit.
Yes, sir.
Understood?
So are these like fixed values for?
Yeah, they found out. You just substitute is very simple.
Yes.
That multiply minus 13.6 to 2, 3, 4, like that, you will get the answers. Do it, no problem. The calculator can do it. Finish. Just multiply minus 13.6 into 2, into 3, into 4, into 5. The divide, sorry. Minus 13.6 by n square. The formula for this is En is equal to minus 13.6 divided by n square. Do it now, you will get the answer. Yeah? That's it. Do we have derivations? Yes, sir. Definitely. All derivations you have to learn. Now 1 mark cards are not there. Don't worry. Okay, 1 mark cards are not there. You have to know all these questions now. Now, next one is what? Line spectra. We will go with line spectra of hydrogen atom. So line spectra, what happened? We found out that H nu is equal to what? Is this clear, all of you? Yes, sir. What are the derivations? Let me finish off this. Only one topic is there now. I will finish off this, then I can relate. 5 more minutes. Maybe. No, not derivation. That's not a derivation actually. It is only to explain the lines, how it forms. Okay. Now, the line spectrum of hydrogen atom. Is it clear?
That's it.
Yeah, what derivation? So, energy in this lesson, radius, energy, and velocity of electron. These 3 derivations are there. That's it. Now, see, when electron is line spectrum of hydrogen atom, H atom. So, what is happening now here? The formula for this is what? You know H nu. See, simple it is. When electron is jumping from higher level to lower level, H into Ni minus Nf. H into Ni minus H into E into Nf. When an electron jumping from higher to lower, just subtract the energy levels. Okay. So what is the formula now? We have the formula. What is En formula? En formula is me square me square by 8 epsilon 0 square H square into N. H square into N square. N square. Suppose just substitute here H nu is equal to what? M E square by, I'm just taking common directly. E square H square, I'm taking here 1 by Ni square minus 1 by Nf square. Finish. Okay. Is that clear, all of you?
Yes, sir.
So, are you understanding, sir?
Yes, sir.
Zayan, Joshua, Juan. Okay, so just substitute that, you got this formula. So what is this? This whole thing is written as R. Okay, this whole thing is written as R. So H will become H cube, right? Yeah. If you bring it down, nu is equal to what? M E square. What is the frequency of the radiation? Means when an electron is jumping from higher level to lower level, it is releasing energy in the form of light. That is H nu. We need to find out what is the frequency of the radiation. So it's just cross multiply this one. It will become 8 epsilon 0 square H cube into 1 by Ni square minus 1 by Nf square.
Planck's constant
Cube. Now what will happen now? This whole thing is written as R. Rydberg constant.
Oh, okay.
It's a constant value.
Rydberg,
So
yeah,
that,
he did what he did, man.
he just found
Substituted the values,
Yeah.
multiplied, he got this man. Tomorrow you find out you will be a Aman square, Aman constant, Sajid constant, like that. Okay, very simple.
This guy.
Okay, these are the constants. Okay, how much he got that value? He found out that value. How much it was? 1.03
now
into 10 to the power of 7 per meter. This is the value he found out.
Yeah.
Okay, so now when an electron is jumping, suppose example, now this is 1. We started with n is equal to 1. N equal to 1.
We don't know the last one, right?
Yeah, n equal to, now this is 2, 3, 4, 5. Okay, this is n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6. If the electron, when you give energy, it goes to the 6th one. It is coming down, the first one, the first orbit. Or it goes from jumping from the second orbit, jumping from the 4th orbit, jumping from here. It can jump from anywhere. All this, when it is releasing energy in the form of light, that is recorded on a spectrum on a photographic plate.
Yeah.
So all these lines are said to be Lyman series.
Visible.
This is IR region.
This is
IR region. Okay, this is in IR region.
Balmer
Is it clear, all of you?
Balmer,
Second one.
yeah, Balmer
Now,
is
when an electron jumps from here to second one, like this. This is what? Balmer series. N is equal to 2. That is Balmer, that is visible. It is visible. Now, what will happen? An electron is jumping from here to this one, or like this, or like this. It is what? Paschal series. Lyman, Balmer, Paschal. Paschal, it is UV region. Now, if we are jumping like this, then it is Paschal bracket. Bracket, that is also UV region, right? UV or IR?
Balmer is visible.
So it's all UV.
UV. Okay. When an electron jumping like this, it becomes fund series. P fund series. That is again UV. Understood now? Finish. So IR, visible, UV. Understood now?
Yeah.
That's it. Is it clear, all of you?
Shit,
Guys?
Because perfectly on that.
Yeah. Is it clear?
Yes, sir. It's coming.
No, open up. Okay, so this is the topic. So only one topic is left: de Broglie explanation of Bohr's second postulate of quantization. I don't know whether this is there or not in the syllabus. You have to check the syllabus and tell me that one. Next class, tomorrow 1:30, I will take the class. Okay, tomorrow 1:30 I am taking the class. You have to just find out and tell me what is the answer for this. So whether this is there or not in the syllabus.
So Zayan is there to meet him.
Yeah, Zahar is there. You want to talk to him? No.
I don't know him, sir. He's there in my class work. I don't know.
Okay. So can you please check one? I will check. Wait. Anyways, you figure out my meeting. Just give me 1 second.
Was the machine working today? That guy.
Not even that is.
Yeah. Man, I'm sure that day also he was working better in day.
No, that guy gave cash.
Yeah, because
He didn't choose card.
Yeah.
He didn't have card.
he's got at 12 dirham only.
I think he got more than that.
No, this is not there. Board's hydrogen. This is not there. De Broglie explanation is not there. Line spectrum is there. De Broglie thing is not there. Okay, so no need to study. Don't waste time on this.
So,
Can you send me? Yeah, all the notes I have sent before also. I'll forward it again. Okay, everything is sent to your WhatsApp. Is it clear? Okay then. I'll send it again. Don't worry. Okay. So you want to talk to them?
No, what did I talk to? I don't know.
Okay. Thank you so much. We'll meet tomorrow then. 1:30. Okay.
So this is Zion to come also.
Zion, will you come on site? Your friends are calling you.
Sir,
You can talk to them.
Zion, I don't know you, but if you want to get good marks, then come